Welcome back, guys. Now I will talk about Hicksian decomposition. First, let me theoretically describe what the problem is and how the decomposition works, and then I am going to work on a particular numerical example. So, as usual, we start with the x versus y graph, right? All right, so the standard the budget curve, income divided by price of good x and income divided by price of y. And the indifference curve, assuming that there's an interior solution. So let's say this is the initial amount of good x the consumer is using. So then the final condition is, well, what we do, we decrease the price of good x to px prime, where px prime is less than px. Okay, that's the idea. And then clearly the optimal point changes, and let's suppose this is where the final consumption bundle for good x will be. Okay, so in the Slutsky decomposition, we wanted to fix the purchasing power and then ask the question, what would be the new optimal under the new prices, keeping the purchasing power fixed. And so that was giving us the substitution effect. Now, however, in the Hicksian decomposition, what we are going to do is the following. So initially, remember, you are choosing x initial and y initial, and so you are achieving some utility level, let's call it u bar. So the thing is, I do want you to get exactly the same level of utility that you get initially, so u bar. So the question is, under new prices, what would be the expenditure that you would need, and what would be the new optimal if I want you to keep the utility level fixed. So what does that mean? So that means under the new price regime, meaning the budget line I'm going to draw is going to be parallel to the second one, the new one. But the thing is, it has to be tangent to this u bar. So I'll try to be as good as I can. Let's say this is the budget. Okay, not too much. So this price line, this budget line and this budget line, they have exactly the same slope, so they're parallel to each other. So that means the slope here is px prime divided by py, which is exactly the same here, px prime divided by py. Here, however, the price ratio is px over py minus, right? So keeping the price regime fixed or the same as the final situation, what would be the optimal demand for you to keep your utility level fixed? All right, so it's this point. Well, then let's call this xm, and you know what? xm is the point where your utility is still u bar under the new price regime. So therefore, the difference between xm to xi must be the substitution effect. And the difference between x final to xm must be the income effect. Why is that? Well, because this black line, sort of bold black line, is telling me the income you need to make you happy as your initial situation. And this income is clearly less than your normal income, your final income under the price regime px prime and py. So therefore, clearly you're not going to consume xm, you're going to consume this guy xf, so the difference between these two must be coming from the income effect. All right, well, again, it's like how we separate the substitution effect and the income effect is just a matter of approach. So Slutsky's approach was, as I mentioned, it wasn't fixing the utility, but it was fixing the purchasing power. Here, in the Hicksian decomposition, we fix the utility level, not the purchasing power. All right, so the purchasing power is varying, but we're fixing the utility. So in order to get it, you have to be careful that this time finding the Marshallian demand is not going to be enough, because this point, this XM, is not the Marshallian demand you're finding. You are finding, so XM comes from expenditure minimization problem, fixing the utility U to X initial, Y initial as U bar, okay? So that's important. So remember, in the Slutsky decomposition, we found the initial X and Y, and then we calculated the purchasing power, and I fixed the purchasing power and found X to the XM under the new price regime. However, here I'm going to calculate XA and YN as I did in the Slutsky decomposition, and then I am going to calculate the utility, not purchasing power, and then I'm going to solve the expenditure minimization problem under this utility and the new set of prices, and then I'm going to find the optimal X. And so that's what I'm going to do. So what I want to do in the next what I'm going to do next is solve exactly the same problem so that we can make a comparison. The Hicksian decomposition and the Slutsky decomposition sometimes give different values, meaning different income and substitution effects, but sometimes they give exactly the same value, so that's perfectly fine. If you remember the example we had, the utility function was equal to ln x plus ln y, and the px, py, and then the income. And if you remember the numerical example, income was 8, px and py were both 2, and then I wanted to change the price to $1, right? So that was the numerical example, and so I'm going to use this one. So let's start with the Marshallian demand. Well, we already did them, so I don't want to solve it again. But let's remember the optimal X, the Marshallian demand was, if I'm not wrong, income divided by 2px. All right, and the Marshallian demand was income divided by 2py. Right? So this is how we found the Marshallian demands. So therefore, that means the X initial is equal to income divided by 2 times 2, which is therefore 2 units, and X final is 8 divided by 2 times 1, px prime, which is 4. So therefore, the total effect is 4 minus 2, which is 2 units of good X. Well, I mean, the total effect is obviously same in Hicksian or the Slutsky decomposition, because it's not a decomposed effect. All right, so now all it matters is how we find this XM value. So the XM value, to calculate it, you have to find U bar level. So U bar is equal to basically U of, I don't know why I put this, so U of X initial, Y initial. And so it is 2 and 2, right? The guy consumes YI is also 2, by the way, because income divided by 2py is again 8 divided by 4. Okay, so ln2 plus ln2, this is horrible. So the utility is 2 ln2, okay? Or basically ln2 to the power 2, ln4, well, whatever. I mean, this is the utility level. Okay. I don't know if I need a calculator, but let's see where we can go with this. So what that means is that in order to find XM, this is the problem you should be solving. Minimize by choosing X and Y. This Px prime X plus Py Y subject to utility of xy is equal to u bar, which is equal to 2 ln 2. Okay? All right. So what does that mean? That means if you write the Lagrangian, it's going to be, well, let's give the numerical values, all right? So px prime is 1, so it's x plus py is equal to 2, it's x plus 2y minus lambda u of xy, which is ln x plus ln y minus 2 ln 2, all right? So the first order conditions, because I did not solve the cost minimization expenditure problem, the cost minimization problem, I have to do all this. So the first order conditions are dl del x is equal to 1 minus lambda over x equals 0, and del L del y is 2 minus lambda divided by y, so because the derivative of ln y is 1 over y equals 0, and del L del lambda is going to give me the constraint ln x plus ln y minus 2 ln 2 equals 0. So if you look at these two equations, I have lambda equals x, yep, and here I have lambda equals 2y. So therefore, because the lambdas are same, x is equal to 2y. Okay, good. So if you plug them here in the third condition, yeah, let's do it here. What I get is ln x plus ln y. So, well, yeah. So instead of x, I'm going to write 2y. So it's ln 2y plus ln y, okay? Equals to 2 ln 2. Okay, so here, be careful. This is, I need a bit more space, so I'm going to erase this. So this is the where I left ln 2y plus ln y equals 2 ln 2. Remember, ln 2y is like, you know, ln a times b is equal to ln a plus ln b. So therefore, I can write this ln 2 plus natural logarithm y plus ln y equals 2 ln 2. And so ln 2, 2 ln 2, I'm going to have 1 ln 2. All right, so I have 2 ln y equals ln 2. Okay, what else? Well, good. I have, I can send this 2 by dividing this. What else? Well, ln 2 divided by 2 is ln 2 to the power 1/2, remember. So that means ln y is equal to ln squared of 2, basically. But the ln's will cancel out, or I just take e to the power ln y equals e to the power ln 2. So that means y is equal to square root of 2. Okay? So, okay, that's why I'm not interested in y, but I'm interested in x. So x is equal to 2 square root of 2. All right, as simple as this. So that means this is the xm, right? And 2 square root of 2, so square root of 2 is like 1.41, right? 1.4 kind of. So therefore xm is very close to 2.8 or something like this, which is less than 3 in the Slutsky decomposition example. So therefore, the substitution effect, in my case, substitution effect is basically xm minus x initial, which is 2 square root of 2 minus 2. All right, so that's it. So in the 2 parentheses, square root of 2 minus 1. And the income effect is basically the remaining of the total effect, but it's x final minus xm, so it's 4 minus 2 square root of 2. And so if you take the 2 parentheses, it's going to be 2 minus square root of 2. Okay? I mean, you don't have to write them this way, but basically that's it. So this is the income effect, sorry, substitution effect, this is the income effect. And as you see in this very specific example, they're exactly the same. But if you do the perfect complement case, they should be the same. And in fact, we can do that. Yeah, let's do that. Okay? So this is it. So the next example is the same numbers, but the utility function is min of xy. Was this the utility function? I totally forgot. I think that was the utility function. Okay, so even if it isn't, who cares, right? So the Marshallian demands x was equal to income divided by px plus py, and y is equal to income divided by px plus py. So therefore, x initial was 8 divided by 4, so 2. X final was 8 divided by 2 plus 1 plus 2, so 3. So it's 8 divided by 3. So the total effect was smaller. And so now I need to find the m, xm. So how do we solve this? Well, the same problem, right? Minimum of pxx plus pyy subject to, so the minimum of pxx plus pyy subject to the utility xy equals to u bar. So what is u bar? So the u bar in this case is u of x initial, y initial, which is basically minimum of 2, oops, sorry. So 2 and 2, so it's 2. So u bar is simpler in this example. So therefore my optimization problem, I'm going to write again, minimum of xpx plus ypy subject to u of xy equals to u bar, which is 2. The problem is, though, I cannot write down the Lagrangian and take derivative. Why is that so? Well, because the utility function, min of xy, is not differentiable. So what does that mean? That means kind of simple. You don't need to find the optimization problem by looking at the Lagrangian, but you can just draw the, remember the idea of expenditure function, right? So in the x versus y graph, I have the utility, if my utility function is min xy, my indifference curve is going to be this. So this is u bar equals 2. All right, so this is x is equal to 2 and y is equal to 2. Hold on a second. Okay, I just checked if there's voice. X is equal to, y is equal to 2. Well, the idea is to reach this utility. So, and the price ratio is going to be px prime is going to be 1, py is going to be equal to 2. So the slope is therefore going to be 2, right? Py minus py, but minus is because it's downward sloping. P1 over py over px prime, so it's 2 over 1. So so the slopes, so there's these are sort of the possible costs. Look, this bundle, for example, gives me utility 2, but the expenditure is way too high. This bundle gives me utility even more than 2, but still expenditure is too high. Well, you know what? This point is giving me the utility 2, and this is the minimal cost I can get, because any line below this is going to give me, yes, less cost, but I will never be able to get utility equals 2. So therefore, this must be the optimal point. All right? That's it, basically. So that means xm is equal to 2. Ym is also equal to 2, but I don't care about ym. Hence, the substitution effect is equal to xm minus x initial, which is 2 minus 2, which is 0. And the income effect is equal to x final minus xm, which is 8 divided by 3 minus 2, which is 2 divided by 3. So that's it. By the way, that also makes a lot of sense, right? This is a perfectly complementary two goods, x and y, and so there's no substitution between these two goods by default, and so the substitution effect should be 0. Whether you are decomposing income and substitution effect with the Hicksian or the Slutsky approach, and which is what we verified basically. So the substitution effect is 0, and the income effect is the same. So here our conclusions, the size of the substitution and income effect are exactly the same for this utility function, but as I sort of shown in the previous example, for some utility functions, the Hicks and the Slutsky decompositions are going to lead to different income and substitution effects. Again, that's pretty normal because the way we decompose the total effect is different. That's basically it. So in the next video, I am just going to go back to the Slutsky decomposition and sort of give a more formal and generic way of finding Slutsky decomposition. All right. See you in the next video.